Alright, so next video here, class. This is Lab 1-1. Lab 1-1 asks us to do some DC meter practice. Okay, that DC meter practice asks us to connect up this circuit. I'm just going to zoom in on it. It's in your workbook or your lab book. Okay, so basically we have our power supply in DC. We've got a negative terminal and a positive terminal. We're going to connect up a voltmeter in parallel to that to give us an understanding of how much voltage is being output. And then we're going to connect up an ammeter in series with the cone heater and then back to the source. Okay, so I'm just going to zoom back out again here, and I'm going to do that for us. Okay, so I do have this set at 0. I've got my power off. I'm wearing glasses, but preference would be to have safety glasses on over top of them. Okay, I'm not really going to color code. I guess I can try my best to color code. I've only got a lot of browns and reds here, but maybe my first true positive and negative I'll connect up with color codes. So I'm going to come up with my negative, and if we look at this guy, he's heading to my ammeter. Okay, I'm just going to choose an ammeter right on this side because it's quite simple. And the meter actually, the drawing asks us to utilize an ammeter with a range of 0 to 2.5 amps. So my first ammeter here only goes up to ½ amp or 0.5. So I'm going to have to go over to this one to the 2.5 range. So I'm going to go negative terminal to negative terminal. Okay. And then out of there I've got to get all the way up to my cone heater. So let's see if I've got a long enough reach. Okay, I do there. So we're going to come out of the 2.5. We're going to go to this cone heater here. Now these cone heaters don't have any polarity requirements. They're not concerned there. Okay. And then out of that cone heater, we've done that. We're now heading down here back to the voltmeter, or back to my source voltage, which is there then. Okay, so here's my path for current to flow. Out of that negative, through my ammeter, up here to the cone heater, and through that cone heater, and then back down to my positive there. So that's my circuit, all right? Then the last thing that they ask us to do is to connect up a voltmeter in parallel with that, and it's once again has to be a DC voltmeter. So this is my positive terminal that needs to go to the positive value here, and the lab shows us that we're going to go up to 25 volts. So I'm going to start at the 0 to 20 volt range, and then we'll move it up to the 200 volt range after that if required. Okay, so I'm going to have to remind myself of that as we go through here. Okay, so I have my lab power on. I'm maybe going to zoom down here, bring this a little closer. Sorry about this. That's the problem with not having a fixed cameraman here. See if we can maybe get these ammeters and voltmeters in focus when I turn the lab power on. Okay, there's going to be nothing for you to witness or look at on the cone heater side, so I'm not concerned about that. I'm just concerned about you guys getting a better idea of what's being output on these meters here itself. So if I turn power on, you'll see the indicator lights come on. So it shows that we have all 3 phases of current or of voltage ready and present. Okay, and then I'm going to follow the lab. It says we need to increase the voltage here to 5 volts output. So I'm going to look at my DC voltmeter here. I'm at the 20 volt range, so this output goes 0 to 200. So because it's meant to be scaled between the 20 or the 200, if we knock a 0 off of each of these, then that means the first notch here, rather than being 40 volts, will be 4 volts. And then we've got 80 volts, 120 volts, 8 volts, 12 volts, 16 volts, and 20 volts in this scale. Okay, so they ask us to go to 5 volts DC. That's going to be tough to kind of fix and figure out. I'm just going to power down for a minute, and I'm just going to connect up a fluke meter in DC so that we can showcase what we're actually doing. That's the beauty about having lab equipment at your disposal. Okay, so I've got DC volts here. I'm just going to come out of the supply, same thing. Make sure I've got my polarities correct. So that's a negative there, positive there. Not that I would damage the meter, but I do want it to display a reasonable voltage. So this thing here, if we can see it, will show us the voltage that we're going to get. Okay, I'll just shift to this side, that way I'm not blocking anything. Okay, so we're at 1.4 volts. Kind of hard to read. Okay, so we know we need to go up to 5 volts, so that would be greater than the 4 there. And my fluke is going to show you 5.07. And we're basically at the 5 line there. Okay, I just connected up that fluke so you have a little bit more of a clear understanding of it. Okay, and the current that we're looking at, we're in the 2.5 scale, meaning we're at the top, and we're little over halfway between the 0 and the 0.5. So I would say that is 0.025. Is that right? Or 0.25, sorry, my bad. 0.25 amps would be the first recorded value. Then they ask us to increase this to 10 volts. So we're going to move that up, past the 8 up to the 10. We're pretty much dead on there, 10.04, and it's sitting there just at around 10 there. Okay, and my current value that I'm looking at now is basically 0.5 volts, which makes sense. If we had only 5 volts being output, we had 0.25 amps, and now that we've doubled the voltage, the resistance has stayed the same, so the current should double as well. Okay, next we're going to go up to 15 volts. Pretty close. Okay, so 15 volts being output on there, 15 volts on my fluke meter, and my current value there is 0.75. So if we were to take it up to 20, which is basically going to bury this guy right up to the 100% maximum, so I got to be careful there. Take it up to 20, what do we anticipate my current value would be? If we've gone up by 1/4 amp each time, so that should mean we're going to come up to a 1 full amp here in a minute. Just going to take this up to 20 without breaking the meter. Touchy. There's like a really finicky spot within this power stat. It doesn't like to be that low. About 19 something. I don't want to take it further, but it's basically almost 20 volts there, and our current is just shy of 1 amp. So we're going to go with 1 amp as our current. Okay, I'm going to power down because I have to increase the range of my voltmeter to 25 volts. My ammeter is still safe. I'm going to power back up again, and I'm going to take this up to the 25 volts that it asks us to take it to. Oops, we're bouncing all over the place here. 1 second. Come on. Sorry for the fidgetiness here. Connection's a little bit squirrely here. It's jumping between 26 and 24 or 23. If I look at the analog side, we're sitting about 25 volts. Okay, and my ammeter is outputting 1.25. Once again, we increased that 1/4 amp. Okay, so we're going to shut down. Next, what they're going to ask us to do is going to...
Hi, you.
Sorry, I'm videoing.
Oh.
Next, what I'm going to do is I'm going to keep the connections exactly the same, and I'm going to measure the voltage being output. I'm going to stay up in the 200 volt range here. When I increase from 1 through 5 amps. So these are steps 7, 8, and 9, I guess. Okay, so we're going to zero everything out again. Power on. Turn the main breaker back on again. Ensure we have the proper polarity. Okay, and then we're going to go until we see 1 amp of current flowing. So we got 20 volts for 1 amp. That makes sense. I got to be quick with this one because we pushed this power supply beyond what it's capable of here shortly. So we're going to go to 2 amps of current. We're there, and that's sitting around 45, 46 volts, or 40 volts, 45, 42 volts. Okay. Now I'm going to shut you down because I need to move my ammeter up to the 5 amp scale. Turn you back on again. Okay, And then they ask us to go up to 3 amps. We're at 65 volts for 3 amps. And then if we're going to 4 amps, we're at about 88 volts-ish. And then they want us to take it to 5 amps. And we're about 110. Okay. Turn that back down, power off, and then we can clean everything up and have a look at our observations and conclusions as a class. Oh, and there's the bell. All right, so that was Lab 1-1, DC meter practice.